Hello world, my name is Victor Engelmann. Welcome back to my channel. A while ago I made this program here, a TCP client, where I would connect to the local host on port 12345 and then would exchange messages between the server and the client. Right, so this was the implementation of this TCP client class. And we had this netcat server running in listening mode on port 12345, and then running this program would connect to that server, and then you could exchange messages. Right? So this is what this program did. And this just connects to an existing server, right? So it's a client socket that you can instantiate, and then you tell it to connect to a server, and it does. Okay, we've just tested this. But when you're looking into TCP, you might also be interested in how to create a server, right? I mean, this is just for clients, and today I want to do the other side of the connection and write a TCP server, something really simple that just waits for connections, and whatever it gets, it sends to all its clients. So very much like a chat server, okay? Like IRC or something. Now, in principle, it's actually not hard to run a TCP IP server. What you need to do is you need to create a socket using the function socket. Then you need to create a listening address through which you can tell your system, hey, I want to receive data on this port. Okay, you specify the port number through that. You can also control something like if you have multiple network interfaces, you can select, hey, I only want to listen on this network interface. You know, if you have multiple network interfaces, then they must all have different IPs. Then you set the IP of the interface that you want to listen on. Then you have to call a function called bind to bind this socket that you've created to this listen address. Okay, and I think you should actually be able to run bind with multiple listen addresses. You know, if you have, say, 3 network interfaces and you want to listen on 2 of them, maybe that could work. But either way, you create a socket, a listen address, then you bind these 2 things together with the bind function. Then you put the socket in listening mode, calling the function listen. And when you do that, then the operating system will wait for incoming connections and buffer them. Okay, you tell it how large you want your buffer to be. Incoming connections will be put in this buffer, but nothing more will be done with them. Okay, so and when the buffer is full, more incoming connections will just be rejected. So what you need to do then is take connections from this buffer. Okay, and you do that with the function called accept. Okay, so once your socket is in listening mode, you can directly call the accept function. It will then block until something comes. Okay, and that then gives you another socket, which you can then use like we used the client socket, right? So you can read from it, write to it, you can close it, just like a file, right? Everything's a file in Unix systems. And the problem with that is if you read from it, for example, then the read function will block until something comes or the connection gets disconnected. So the problem is you don't know what happens in which order, right? While you are waiting for a packet from this client, a new client might connect, right? And if your thread is now blocking because it's waiting for data from this client, then yeah, the connection to the other client will just time out at some point, and yeah, that would not really work well. So there is actually this way with a function called select and poll, which I think allows you to wait for different sockets at the same time. But yeah, I could never wrap my head around how to use that. So I'm not gonna tell you how to do that because I don't even know myself. What I'm going to do is I will create a new thread for every new connection. Okay, so so I will call accept, waiting for a connection. When it comes, I start another thread that then communicates with that connection, while the other thread, the first thread, then cycles back and starts accept again to wait for another connection while the other thread handles the first connection. Okay. And I won't go into this whole multi-threading stuff because I've made a video about that already. So I will just start threads and use mutexes without much of an explanation. But yeah, I want this again in a very object-oriented way. So I want this server to be like just an object that I can put somewhere and tell it to do its thing. And I don't want a function that I call on it, something like a start function or so, to block. Okay, and it would block if I just cycled through the accept functions and started threads, right? Because in the thread, this loop that accepts would then not return, right? So the call to that function wouldn't return, blocking the thread that starts it. And yeah, I don't want that because what do you know? I mean, you might want to have multiple TCP servers in the same program or something. So I want this to be just an object that's there and that does its thing, okay, without bothering me as its user. I want to tell it, hey, do this. And then I want it to do it without without bothering me. So I don't want to be forced to run this in a separate thread just so that it doesn't block. Okay. So what I will do is I will run this loop that accepts new connections and starts new threads. I will put that also in a separate thread. Okay. So yeah, that will make this whole deal much more complicated, but it will be much nicer to use then. Okay, but keep in mind, fundamentally what you are doing is you create a socket, a listening address, bind the socket to the listening address, put the socket in listening mode, and then you call accept on it, getting new socket handles for the different connections, and then we run these in separate threads, reading data and yeah. Okay, so let's start doing that. So as always, I will start from scratch with a makefile. A main CPP. A TCP server header file. TCP server source file, and we will need another class for the connection. Okay. Okay, I've loaded everything in Kate. And yeah, the makefile is quite simple as always. You know, I make pretty much the same makefile every time. So if I want to create an object file from a CPP file, it also depends on the corresponding header file. Then I want to output the destination file and compile the input file for it. Okay. And to create the program itself, TCP server, I will need TCP server.cpp, or no, the object file. Object file for the client connection. And yeah, we don't have a main.h, so I will just put the main CPP here. And with $head, I put all the parameters here into this command. Okay, this looks already pretty okay. Okay, so I will include TCP server.h. And in here I will instantiate the server, and yeah, I don't think I need constructor parameters, so this would be enough. Okay, so I will start the TCP server and have it listening on port 12345. Okay. And yeah, I think, yeah, let's put a lambda function in here that reacts to the messages. For now, let's just write the message to standard out. Okay. Now the TCP server class. First an include guard. Okay, we will have a constructor, a destructor, a method to listen, which gets a port number, a stop method. Okay. Now let's implement a bit for this. Well, one of the main things that this class will do is it will manage a list of connections. So yeah, for performance reasons, I like to use vectors. Okay. Good. So this is where we will keep references to all the connections to the clients. Okay, we will have a client connection and yeah, we will need a method to send something to the client. And yeah, okay, so the server will have a list of objects of this type here, client connection. Okay, so I've created stubs for all the methods. Okay, and let's say make TCP server. Of course, well, that's what you get when you create the stubs using copy and paste. Yeah, I had the include guard here also, and that then prevented the inclusion of the TCP server.h, because I defined the define variable and then including the TCP server.h skipped this whole file because of this include guard. Because the compiler thought, hey, I already did include this. Yeah, okay. Okay, I don't have, yeah, of course. Okay, and include client connection.h. Okay. I mistyped client connection here. Okay. Yeah, okay, I haven't added a lambda to the parameters of the listen method. So let's do that now. Okay, so we can now compile. Now we have to fill all these methods. The idea with a server socket or a TCP server object is that you have multiple sockets, right? And each of these sockets can deliver data at any time. You have no indication where do you get data. So yeah, there is this select function that I never really understood, which would allow you to kind of listen on multiple streams at the same time, and the operating system manages it in some way. But as I told you, I have never understood how to use that. So what I will do is I will create a new thread for every connection. Okay, so every connection will have its own thread listening on that connection, and yeah, when data arrives on that connection, then it will call this callback function and put the data in there. Okay, so how do we do that? Well, first of all, this listening here in the server, I will run that in a separate thread also. Okay, so how do I create threads? Well, if I start listening, I will need a raw function, a C function for that. And these functions are typically called something with thread proc or thread procedure. So if we are already listening, we won't do anything. Okay, so we will need a Boolean variable for remembering if we are already listening. Okay, yeah, when we create the object, then we set that to false. We will need a listening port. So here we put this port, and yeah, let's initialize that with some invalid port number, -1. Okay. Okay, and yeah, now we have to create a new thread. Yeah, we need a handle for a thread for that. So pthread t. Of course, in reality, we wouldn't hard code the multi-threading here. In reality, you would put that in a separate class, of course. We've written such a class in one of the previous videos. Yeah, but yeah, listen thread. And yeah, here we now pass this listening thread to pthread create to create a thread. No options. Then this is the function we want to run. And as a parameter, so this function gets a parameter. And what we put here, this function will get. and I will pass this pointer to it. Okay, and this should return 0. Okay. Otherwise, we'll throw whatever, listening error, whatever. Okay, so now when we run listen, this thread is created. Okay. And the thread runs this function here, but this is a raw C function right now, so I want to get back into the object-oriented world. So yeah, what I will do is I will cast this parameter back to a TCP server. Okay. And on this object, then I will call the method listen thread proc. Okay, but I will protect that with a try catch. Okay, and yeah, at the end of this thread, we just return null, because yeah, this has a return type void star, so we have to return something, but I don't want to return anything. Okay, now we are not passing the callback. Yeah, I think I will have to store that in here. So okay, because otherwise I don't think we can get this callback through this function back to the listen thread proc. Good. Okay, now this method will be running in this separate thread, and in here we now really start listening. Okay, so everything up here was just setting up this thread, and yeah, when we come here, the thread is running, and here we now really create the socket and put it in listening mode and everything. Now in here we will call the function socket to create a socket with parameters AF inet for an TCP IP connection, socket stream, and no options. Okay. Okay, and yeah, this method or this function will return handle for the socket. Which will be yet another field in this class. Okay, so now we have a socket. So socket might return a negative value, and you'll have to react to that. Like if we get an invalid socket handle for whatever reason, then so yeah, if we get a socket handle below 0, that's an error. Then I will set a socket option to reuse the address. So if we don't set the this option, then after closing the socket, the address will be just yeah, for 2 minutes the program will refuse to accept new connections on that socket. Because 2 minutes are the lifetime of TCP packets. So if you close a socket, there might be something still on the way, and that could potentially confuse your new socket, right? Because it might get data that was meant for the old socket, but yeah, that's very unlikely, and because of that, I will configure the socket to just not wait these 2 minutes. Okay, so for reuse address, I pass this enable, but that's an L value reference. That's why I put this as a variable here. And this might again return something negative if we have an error. So okay, and now we have to bind the socket to an address, so so that the network stack will then compare this address to the data that's coming in, you know, from the IP header, and say, okay, this is a message for me, I will accept it and not throw it away or something. So for that we need a sock address in, which I will call server address. Oh, let's use camel case again, but that's a struct, and that is in arpa/inet.h. Okay. Okay, so now we configure this server address. First we will zero this object okay. Okay, so as in family, we configure this to use IPv4. We configure the port. To the listening port. Okay. And we configure it to accept data for any recipient. You know that we are setting the listen address to 0000, which means data on any network interface will be accepted. If you had multiple network interfaces and you only want data coming from one of them, then you could set this to the address of that interface, but yeah. I'm not going to do that here. So server address dot sn address dot s adder equals in adder any. Okay, so that's 0000. As a listening address, we will accept any incoming data. Okay, and now we bind the socket to that server address so that the socket knows which data to accept. Okay, so the socket handle is bound to the server address. And again, if that returns something less than 0, it's an error. Okay, now at this point, the socket is prepared, everything is good, and we can now finally call listen. Okay, we are finally there. We listen for incoming connections on this socket. And this needs another parameter. I will give it 5, which means that it will keep up to 5 connections at the same time. So if you get a lot of connections at the same time, they might have to wait for a while before you accept them. And yeah, this defines how many sockets or how many connection attempts you are willing to buffer before you start rejecting incoming connections. Okay, now once this is done, I will set is listening to true. And while that's true, yeah, I will accept incoming connections, and I think I should set this to volatile so that this is not optimized out to a while true, right? In here, we now here we now have a loop, and in this loop we create an object of type client connection, right? And yeah, this client connection is then waiting for a new connection on that socket. Okay, so when a new connection on that socket arrives, so this object here will take that connection and handle it. Okay, but then this while loop will go back up and create a new client connection object that will then wait for the next connection. Okay, and with that it will do the same thing. If a connection comes in, it will take that connection, handle it in a separate thread, and then go back up, create a new client connection object, and so on. Okay, so we create that thing, and on this we will run accept for the socket handle. So we will tell this client connection to wait for a new connection on that socket and accept it when it comes. Okay. But if this method returns false because something else happened, like we are closing the program, then we will just delete the connection and break the loop. Okay. And yeah, if we get out of this loop, then we set this is listening back to false. Okay, good. Now, so this connection accept will return true if the new connection is successfully accepted. And yeah, now we will store this new connection in our list of connections. So okay, so our connection vector here now takes this connection, and then it's just enqueued and everything's fine. But yeah, this list is accessed from multiple threads, so we need some thread synchronization. And that means we have to add a pthread mutex t, which we will initialize in the constructor. And in the destructor, we destroy the mutex again. Okay. So yeah, when we access this connections vector, then we will need to have this mutex locked. Okay. So we are not allowed to use this connections array here without having the mutex locked. So that's why I did this here. Okay, so how do we now accept a new socket here? how do we accept? So here we get, well, we will call the accept function on the listening socket, and this will return, well, a new socket handle. So let's call it connection socket. Okay. So this gets a handle to the new client socket. We need to give it a reference to a data structure to store informations about the incoming connection, you know, like the stuff we did up here, right? This is what the library will do and give us a result, give us the infos about the incoming connection. And we do that with the another sock header in. Client address. So now we pass this client address object yeah, this function will also return the length of the data that it writes in here. But that's again an L value reference, so socklen client length equals size of client address. Okay. Okay, so this all here is now filling this client address and consocket with informations about the incoming connection. If client socket less than, or connection socket less than 0, then, well, this is what we get from accept if we shut down the server. So at this point, this accept returns, but not giving us a new connection. And in that case, we just return false, you know, to break out of this loop here, right? Then this tells this loop, okay, we are done listening, right? Okay, and yeah, now we have to start the thread on this client to handle that connection, right? So again with pthread create, for that we need another thread. Monitor thread. So here we now create a thread now. Again, we have to give it a Sieve style function. Client connection monitor thread procedure. So this function is what we will be running. And again, pass it this pointer. Okay. So we create a thread that will run this function here. And again, what we did in the other case, yeah, we will cast this pointer here back to the type client connection. And step back into the object-oriented world by running monitor thread proc on this object. Which will again be a method of that class. So yeah, we'll put that in a try catch block again to protect ourselves from anything going wrong in that object. What I will do now is I will detach the thread which means that at the end of the thread it will not wait to be joined, it will just be disposed. Okay, and so then I don't have to worry about freeing that thing, joining it, when do I join it, and so on. Yeah, this has a negative side that I've created this client connection object somewhere, and yeah, I don't want to have a memory leak, so at some point I have to delete it. And since yeah, this object yeah, is in this thread to which I don't have any access anymore later, I have to delete it somewhere in that thread, so I will delete it here at the end of this thread proc. Okay, and pthread detach. Okay, and in this case I return true, because this socket is now connected after this accept, and the server object will put it in its in this connection list. Okay, now this starts the method monitor thread proc on this client connection object, but this method doesn't exist yet. Okay, what do we do now in this monitor thread proc? Yeah, we are basically just waiting for data on that connection. Let's say we use a buffer of 255 characters. You know what, let's take 2048 so that we can take an entire Ethernet packet and don't have to chop it up. Okay. Okay. Okay, let's store a state that tells us if it's connected or not. In the constructor, we'll set that to false. Here we set it to true. Now we go into an infinite loop that reads data from the socket. So we are reading from the socket into the buffer. At most buffer size many bytes. Now if this returns a value less or equal to 0, that means the socket has been closed. So in that case we break and set is connected back to false. Okay. Okay. So the socket should already be closed at that point, but just to be sure, I will close it again. Okay, and up here, if this returns something larger than n, then we have gotten some data. So I will instantiate a string which takes that data and the number of bytes. That's one of the constructors of standard string. And now we have to give that data back to the server, because the server is the thing that has this callback function, right? So for that, the client or the connection object needs a pointer to the server. So the server will pass a reference to itself to the constructor, and okay, so now we have a pointer to the server, and if we get data, then we can use it to call something message received. Okay. So this TCP server now needs such a method. Okay, yeah, a pointer to the object where the data is coming from, and yeah, the message itself. Okay, and yeah, I think we'll just call the callback with it. The client connection now gets a pointer to the server as a parameter to the constructor. Okay, so we pass this pointer here. This is looking pretty good. Let's look over the code. We instantiate the object and tell it to listen, right? We listen, creates a thread, which runs this method, which creates a socket, a listening socket, and configures it, binds it to the server address, and listens on it. Now, in this loop, we create connections, waiting for new clients. When a new client arrives, then the accept method takes the client and runs the thread on it, and this is stored in our list of connections. Okay. Yeah, this creates one connection object waits for a client. When the client comes, then the accept method, this accept here, will then return the infos about that connection. We then create a thread running this thread proc on that socket. We are reading the data. If something arrives, we turn it into a string, pass it back to the server to message received. Message received gives it back to the callback, which prints the data. So okay, let's try this. Let's compile it. Pointer here, let's just forward declare TCP server and remove it here. Yeah, the thread procs should be here. These functions aren't forward declared, so they have to be defined before the method that uses it, right? We could forward declare it, but yeah, let's do it this way. To use standard C error, we need IO stream. Okay, B0 in TCP server CPP. As C library strings.h. Okay, client connection. Okay, we are calling a method on the server object, so at this point we need the definition of the server. Yeah, then read and close in file control. sources in Unistandard. Okay, this is looking good. Okay, it immediately comes back, which makes sense because the listen just creates a thread, right? And the thread can do whatever it wants, but yeah, this listen is then finished, so the main thread here is then returning and returning 0 here. So maybe I'll just wait for some input foo. Okay. So just to block the main thread. Okay, now it's waiting. Where the TCP client tries to connect to localhost on port 12345, right? Which is the same port we are using here, so the TCP client should be able to connect to it. Hey, look at that, it says it's connected. Connection established. Hello. And hello has arrived. That is really, 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 really good. Now we want to send this data to all the clients, right? So we will need some way to send something. Let's say on TCP server, I will have something like a send with a client connection. Okay. And this will just forward the data to a method of the client connection. Okay. Yeah, this method here. And in here, yeah, let's first check if is connected is true. Okay. Now we can just like in a file, we can just write the message to the connection socket. Okay, here we basically look into the internal data of the string object, the memory location where the data actually is, and as many bytes as the message has, we write to the connection. Okay. And if this fails, So if we cannot write everything, then okay. Good. So with this, we can now send. But here in this event handler, we only have the message that we've received, right? So yeah, we will have to expand this a bit. Let's put using namespace. Okay, so this is where the data is coming from. Okay. And yeah, let's also put a pointer to the server. And this was supposed to be source. Okay. Okay. Good. Now the callback has the corresponding signature. Okay. Good. Now if we receive a message on a connection, then we will forward that connection to the callback and this pointer. Okay. So now the event handler receives the information where this data is coming from. And now we can do something with it. Like we could just send the message back directly. Source send message, for example. Okay. You see now if I send hello, I get hello back, okay? Because everything I get, I send back to the sender. So the sending works now, but we don't want to send the data back to the sender. We want to send it to all the other connections, right? So in my old code, I had a method I called broadcast, which sent it to all the clients. But I want to do this more in a more functional way with lambdas. So I will give the user the ability to iterate through the client connections for each client. A standard function okay. So this will then invoke this lambda function called body for each client connection. Okay, and yeah, I cannot just give the user of the class direct access to this connections here, because yeah, it's that's a thread synchronization problem, right? We have to lock the mutex, and that's basically the difference between using this and just giving the user access to the data directly. So we will lock the mutex. Iterate the connections. Okay, for each connection, and we are now allowed to iterate them because the mutex is locked. And for each of them, I will invoke the body on the connection. Okay. This looks like it should work. Okay, so now we then are able to run server for each connection, a lambda function, okay, and what will we do as the body? We will send the message to each connection, and yeah, we have to capture the message. Okay, this looks like it should work. Let's try it. Yeah, the name was for each client, sorry. Okay, run the TCP server. Client 1, hello. Okay, I get hello back because I'm sending this to all clients, including the one who sent the data. But now run a second client. Now this message from the second client is also sent to the first client. You see this here is the first client, and it gets this world from the second client. This is really good, but let's only do this for cases where the connection is a different one than the source, because yeah, if I'm sending something like here, I don't want my own data back, right? It's already written on my screen, so why would I want to get it back? Oh, sorry, we are not capturing the source. Okay. Now let's run the TCP server again. Connected. Hello. Now I don't get my own data back, but yeah, my chat partner gets my data and what the chat partner sends comes to me. Okay, this is looking really good. This is now an actual working chat server, right? You can now exchange data between clients. But yeah, now we have the problem, what happens if one of these clients disconnects? Like Control C. Now, okay, the other client doesn't get notified, of course. The TCP server realizes, hey, the connection is lost. But yeah, if I now try to send data from the other client, error in monitor thread proc. I don't know why this error message is printed here, but yeah, anyways, the problem, of course, is we have a disconnected socket and we are still trying to send data there. So what we need to do is we need to notify the server when a client disconnects, right? This is something that the client connection finds out, right? Here, this if this read fails, then the connection is lost. Yeah, here we should notify the server. Okay, so we need something like an event handler on the server. Okay, now when this connection disconnects, then, well, we should throw it out of our connection pool here. So we have to lock the mutex again, because we are now accessing this connections list again. So how do we throw this connection out now? Well, we first look for where in our array is this connection. And then okay, so we look for an iterator where in our connections array is the connection that has been disconnected, and if it's found, then we remove it from the connections. Okay, so then when new data arrives, we don't send it to that disconnected client anymore. And I think the standard find is in algorithms, if I'm not mistaken. algorithm. Okay, so now if we connect two clients, hello, disconnect, world. Okay, yeah, connection lost, but yeah, now we don't get an error because yeah, we received the world, but we haven't forwarded that to any client, right? Okay, now we are pretty much done, I think, except yeah, I also want to have the ability to stop an already running server without killing the whole program, right? So I want to implement this stop method here. And yeah, I will also call that here in the destructor. So if the object goes out of scope or is deleted, then I want to cleanly disconnect all clients and stop the threads and stuff like that. So the stop method. So what do we need to do to stop the client? Well, if it isn't even running, then we can just return directly. Then I will set is listening to false so that this loop here terminates. Right, I don't want this loop here to go back up and try to accept more incoming connections. So what we need to do is we need to shut down the listening socket with parameter shut rd. Close the socket. So we are not accepting any more new clients. Then I will pthread join the thread for this server. You know, the thread that's running this client connections here. But the still existing clients still could call some functions that use this connections object. So I need to lock the mutex again. Okay, and disconnect all clients. And throw away all the objects. The objects themselves are deleted by their individual thread procs, right? So yeah, now we need to implement a way to disconnect a connected client. Okay, and in here, well, only if it is connected. If it's not connected, we return. Yeah, here we also shut down the connection socket with shut RD and close the connection socket. Okay, now this close should make this read here abort if it's still waiting in there. Okay, and then yeah, we will get an n less than 0, so we will break here. And yeah, then we call this client disconnected. Which yeah tries to lock the mutex again. Yeah, but this will not work because the mutex already is locked in this case, right? If we yeah, stop the connection, we already have locked the mutex, right? And then this additional mutex lock will not work. This will just block the whole thread. I think I will yeah, just have another volatile bool is stopping, which I will initialize with false. Then here in stop, I will set as stopping to true. But let's move that into this protected block so that this variable is also protected. Okay. So I already have the mutex here, and then yeah, this then I will just ignore these client disconnected messages because the connection object is cleared anyways here, right? So I don't have to remove each connection individually, right? So I think that should do the trick. Okay, and of course we want some way to test this, so I will read a command, and if the command is stop, then I will stop the server. Yeah, you know what, let's just move this whole listen call down here. Okay, now the server will not automatically start. We will have to manually tell it to start. Okay. Yeah, here this thread join needs a pointer where this joined thread puts its return value, right? It's this is a void star function that is running on the thread, right? And then when I join it, it wants to have this. It wants a pointer where to put this result here, but I'm not returning a result anyways, so I will ignore that. Maybe I should have also put something like okay, now let's build it again, run. Now, remember, now the server isn't automatically running, right? So if I try to connect it, I don't get a connection, right? I have to start first. And oops, now I can connect. Connection established. Another connection. Okay, data is going back and forth. And now let's stop the server. Connection lost, connection lost, connection lost, connection lost. Okay. Yeah, this is actually looking good, right? So if I try to connect now again, then I can't connect, right? Because the server is stopped. If I start it again, now I can connect again. Okay, and now let's quit. Yeah, connection is disconnected. I wanted to end the video here, but while I was cutting the video, I thought about why we had this error message, this error in monitor thread. And yeah, when I thought about it, I noticed actually multiple problems that we have here. So what happened must have been this. We had these two sockets, right? And we closed one of them, but the object was still there, right? And the other one received data and went through all the handling steps and finally came to this client connection send, okay? And it tried to send to the closed socket, and this just didn't work. And yeah, I don't know if this case here has thrown the error or this, doesn't really matter. The point is an exception was thrown at this point, and well, this has really gone through the entire stack back to this client connection underscore monitor thread proc, right? And here, this is the message that we've gotten, right? And yeah, this shouldn't happen, okay? an exception in this high-level send method shouldn't go all the way back down to this low-level thread controlling function here, right? And yeah, okay, what happened? Well, who calls this send? This is here, right? And well, we are looping through all the connections and sending our data to all of them, right? And yeah, this an exception in this send shouldn't end this loop, right? If we have, I don't know, 10 clients and the 5th throws an exception, you are not sending the data to the other 5, right? So this should be protected with a try catch. Also this iteration through all the clients, right here, where we have locked the mutex, and if we throw an exception in one of these bodies here, then we bypass this unlocking the mutex, okay? So the mutex stays locked, and at that point the server won't do anything anymore, okay? So if we had sent another packet of data to the server at that point, nothing would have worked anymore because yeah, the server would have been locked. So here we should also protect ourselves at least with a try catch, and then the catch should unlock the mutex and then maybe rethrow, because I mean a loop shouldn't just catch an exception and ignore it, right? It should rethrow it, but yeah, this mutex must be unlocked. Okay, then who does the message received? That's here. Okay, yeah, when the connection is broken, this monitor thread proc ends, right? And then this monitor thread proc ends, and it deletes the connection. But on the client side, we didn't see the connection going away, right? And that's because here this destructor doesn't disconnect. Okay, but even if it did, at the point where we had this error, the disconnect method hadn't existed yet. So so calling it here wouldn't have changed it. But yeah, if the thread here crashes, then yeah, the connection should be closed, right? It shouldn't look to the client as if the connection was still there if the thread has crashed. So yeah, if we delete the connection here and have a call to disconnect here, I think that's enough to make sure of that. And yeah, anyways, that's all I wanted to show you today. If you liked this video, like it, share it, subscribe, and see you next time.